Hello and welcome. I'm Saeed from storyplanet.net. Dive right into the essence of the most captivating books without reading them cover to cover. Whether you're on the go, at the gym, or just relaxing at home, we offer you a unique and enriching listening experience. Today, we are exploring the Book of Why, a creation by Judea Pearl and Dana MacKenzie. The Book of Why, 2018, explains statistical argumentation and advocates for a mathematical approach to understanding causation. It challenges the long-standing notion that correlation does not equal causation, which has hindered research progress in various fields for years. The book aims to counteract this impediment. Before we delve into these revelations, it's interesting to note that Judea Pearl, a computer scientist and philosopher, received the prestigious Turing Award in 2011. He authored renowned books including Causality. Dana MacKenzie, a mathematician and writer, is known for works such as The Universe in 0 Words. With 8 key ideas to unveil, brace yourself for a deep dive into this captivating book on storyplanet.net. To start, this text encourages readers to challenge their basic assumptions about data and consider what benefits lie in doing so. The text discusses the importance of understanding cause and effect in various situations, emphasizing the need to differentiate between causation and correlation. It mentions using math and statistics to analyze factors affecting outcomes and warns about distinguishing true influences from misleading ones. The text also highlights the authors Pearl and MacKenzie, who challenge common mathematical beliefs and suggest insights on improving decision-making. Key idea number 1. Some statisticians have criticized the concept of causation. The text discusses the historical perspective on the phrase, "correlation does not imply causation," coined by English mathematician Carl Pearson in the early 20th century. Initially, causation was downplayed in scientific research. However, geneticist Sewall Wright showed that causation could be mathematically represented in his research on guinea pigs. Despite facing criticism, Wright's work is now being revisited as fields like medicine and climate science are embracing causation as a principle, suggesting a growing causal revolution. Key idea number 2. Data can be misleading if causality is not considered. Data collection is crucial for understanding root causes, but must be properly analyzed to avoid misinterpretation. An example with the smallpox vaccine shows misleading outcomes when statistics are not thoroughly examined. Looking beyond the surface data, considering common causes, is essential to grasp true connections. The ladder of causation method helps delve deeper into data analysis to uncover more accurate insights. Key idea number 3. The first rung of the ladder of causation focuses on association and probability. Humans have a natural tendency to make connections and seek causation in the world around them. This fundamental thinking puts us on the first level of the ladder of causation. Despite this innate skill, machines and AI struggle to progress beyond this basic level. Self-driving cars, for example, are limited to reacting to observed data and cannot predict various potential scenarios. Data collection and statistics operate at the same basic level, primarily focusing on correlations rather than cause and effect relationships. This emphasis on observation alone lacks the depth needed for more complex analyses in many circumstances. Key idea number 4. Intervention is important in both daily practice and research. Humans advance in the ladder of causation by actively influencing outcomes, unlike computers which remain limited to the passive observation of the first rung. Controlled experiments, like the one involving Daniel from the Bible, help measure variables objectively and in isolation. Modern examples include Facebook's experiments with web page layouts to compare different user interactions. Key idea number 5. Understanding counterfactuals is the third and final step in the process. Humans uniquely possess the ability to imagine different interventions and outcomes, often using counterfactual models to do so. Counterfactuals are common in fields like climate science and legal proceedings. Machines lack the ability to distinguish between necessary and sufficient causes in causal relationships, potentially leading to different conclusions than humans. Understanding the three rungs of the ladder of causality is important in answering causal questions and considering complicating factors in scientific studies. Key idea number 6. Controlling for confounders is crucial in determining causality. Controlled trials are important, but results can still be misleading if confounders, which impact participants and outcomes, are not considered. Confounders, like age differences in test groups, must be controlled to ensure accuracy. Randomization helps control for confounders, as seen in the use of placebos to prevent biases. However, randomization is not always feasible or ethical, necessitating careful consideration of confounders in research design. Key idea number 7. A mediator's role is crucial for determining accurate causality. Understanding causation is important, but identifying why something causes another is crucial for prevention and treatment. Mediators explain how one factor leads to a specific outcome, like smoke indicating a fire. Mediators are essential for establishing causality and are associated with counterfactuals. Misidentifying mediators, like in the case of scurvy, can lead to fatal consequences. In the example of the British Arctic expedition, mistaking lime's acidity for vitamin C led to misdiagnosis and scurvy outbreak. Recognizing mediators correctly is vital for successful prevention and treatment, as seen in historical cases like scurvy outbreaks among sailors. Key idea number 8. Relationships between factors can be represented using mathematical formulas that can be converted into algorithms. Reflecting on causation and determining if correlation implies causation is critical. Causal diagrams and mathematical formulas can show the relationship between correlation and causation. Healthcare specialists use diagrams to identify factors affecting outcomes, like drug effectiveness. The methodology can be programmed for AI, allowing computers to ask and answer causal questions, leading to significant advances in science and medicine. In conclusion, understanding causation is crucial in research to avoid hindering scientific progress. A logical process can determine when correlation implies causation. Implementing this method could enable computers to answer causal questions, leading to advancements in scientific rigor. Feedback on the content is welcome at storyplanet.net. Further reading suggested is Mindware by Richard E. Nisbet, which delves into reasoning and cognitive tools used by statisticians, logicians, and philosophers for approaching problems objectively. Thank you for listening to this summary. If you enjoyed this exploration, we invite you to discover other fascinating books on storyplanet.net. Don't wait any longer. A multitude of books, stories, and knowledge await you there. See you soon on storyplanet.net.